can hear us without any difficulty. My name is Jaime López Craig. I come from the Paris University, and I've been once again allocated this room. I was also allocated this room yesterday, so here I am again. We're going to start with the three speakers, mostly ladies today, so it's very good. And we will have, first of all, Elena, interaction, voice-based in a digital home. It will be delivered by María Mercedes Fernández from the Engineering Polytechnical School of Madrid. Engineering Department at the Polytechnical University. Well, as Jaime says, I work at the Polytechnical University in Madrid in a life supporting technology where we have developed a voice-activated interface based in natural language called Elena. So we're going to see a brief introduction about the current situation, particularly concerning what we have available regarding voice recognition, what were the tools and the targets. Regarding the Spanish language, what were the different syntactic structure and the method adopted to implement this interface development, the assessment, and we will give brief conclusions. According to the statistics delivered by the European Statistics Office in 2007, 38 million people in Europe suffer from some kind of disability. If we were to think only about active population, 65 minus, below 65, we have 5% of the population. 60-year-old, within 60-year-old is 15% of the population. These statistics have increased in the past few years. We've also seen how most people prefer living in their home as opposed to being sent to a home or depending from a family member. These studies prove that for the person, this is really benefiting for their own non-dependence. So we're going to use the technology and the communications based on ambient paradigm to set up the right environment for these people. Through ambient intelligence, what we're trying to do is to set up a few spaces so that the users can interact with different systems. This interaction should be natural and should not entail an additional effort for the person. These support technology are based on ICTs, and this technological part should be like invisible because it's very complex for the user. If we think about the life support products that we use, only 50% of people suffering from some kind of disability use this product. And these products related to environment control are the less requested. The domestic system, we thought about them as a potential help for these people. The main problem they'll have is the high cost. With regard voice interaction, we find that the systems we have available in domotics, voice-based, are command-based, fixed structure-based. So what are the problems derived from this fact? If the user needs fixed structures, it needs prior learning of the command. Not just any kind of combination of words would be ideal to reach a function. The system normally depend on the user, so the user requires a prior training about the device to use it. So the consequences are that the user doesn't really end up getting used to this as a natural interaction. It needs a lot of preparatory training to be able to use it in a beneficial way. So the target we considered was to develop an interface communicating with a digital home and as close as possible to natural language. 3 items. First of all, independent from the user. So we wanted to get rid of this preparatory training. Lack of command, so the user didn't have to remember a particular command or combination of words to start an action, and always having some feedback, offering feedback for the user, so the user always knew and was in command of what was being done by the system. So if we were to, before we start with development, it was necessary to do a preparatory study to see how the Spanish language works. We have 2 types of orders, the lineal order and the wrapping order, so the surrounding order. So the lineal order is structuring the ideas that you want to express. It is fixed. It is subject, verb, and complements always indirect, direct, and circumstances of the effect. So in the Spanish language, we tend to use a surrounding or environmentally surrounded order, depending on where we want to place our stress, is much more free. Then we have differences in pragmatic places. We'll see that in real life. The method we use was user-based, so we developed a dialogue system based upon a number of parameters. First of all, the voice that could be selected. It could be feminine or masculine. The existence of voice recognition automatically, setting up logic in the sentence, vocabulary, because this is a digital home, it would be very limited. Feedback for the user, that should always be present, and who would have the initiative in the dialogue, in the interaction, man-machine in our system. In this case, the initiative will always be with the user. So there is a limited use of the natural language, but the digital home has a number of devices that can be located, so really the vocabulary is not as rich as in the Spanish language, and the interaction is limited to a number of devices. So through this diagram, what we have is an explanation of the system. The system is always on standby until there is a voice event to be recognized. Once the voice event starts, there's a syntactic analysis. If the outcome is positive, then it would be semantic analysis. Otherwise, there's feedback to the user indicating that there hasn't been a completion of the syntactic analysis. In the semantic analysis, we analyze the data. If there's no positive outcome, then again, feedback to the user. And if the semantic is done correctly, then we want to performance to the execution of the order. And this is always feedback going to the user. So once the order has been executed correctly or incorrectly, then we go back to standby. If we look at each and every one of the stages, we see that in the syntactic analysis, we have defined 2 large groups, different operations. On the one hand, inquiries that the user may launch, and then the actions that the user may carry out. A number of parameters define the transaction of the operation to be carried out, defining the device, the location, and the action. And the structure the system recognizes has to coincide with one of the structures gathered in a part of the system, stored in a part of the system. So the system has a storage where all the syntactic possibilities are stored. So what the user says has to coincide, at least has to match at least one of the choices existing in the storage memory. So this is the action the user wanted to open living room window. So in this first structure, that would be the linear order. I want to open the living room window, but we can have a different type of surrounding structure. I want to open the bedroom door, I want you to close and the window and open the door in the bedroom. So there's a multiplication in the order of the different components. The system is trying to do a syntactic analysis and trying to find matching. They wanted a connection, an action, an element, and a location. In this first stage, there is no need for this consistency. Only this, just the order has to be a bin. And then we go to the next stage, which is the syntactic analysis. First of all, they want to find consistency between the existing element. For instance, between the verb and the device they want to act upon. So find the window, and switch is what they recognize. So there's no connection between switch and find as verbs, so the syntactic analysis would not be accepted as valid. There's no matching of the verbs in the sentence. So also there should be consistent message between what the user recognizes, between what the system recognizes the user is requesting and the location in the home. In other words, if the window in the kitchen is open and the user asks for the door to be open, the semantic analysis will recognize that there is no consistency between the order given by the user and the current situation of the location. So it has to be a matching, and then if not, there is a feedback to the user. If there is any inconsistency between the request and what the system is understanding, then there is a dialogue man-machine set up in such a way that if there is no consistency, for instance, or there is a missing element, the system would feedback the user and would launch an inquiry trying to find other missing data. So if there are 4 windows and the system has only recognized that the user wants to open the window, so for the system, it's not a problem with the semantic analysis being wrong, but it's incomplete. So it's going to feedback to the user and say, which window do you wish to open? Trying to complete the information missing. So this is a diagram, a flow chart of how the semantic analysis would work. In this case, trying to set up the oven. If you want to set up the oven, obviously you don't need to indicate the location because there's normally just one oven in the home. So the system will detect the oven, will find the right recognition to see whether or not there's been a time mentioned. And then if there's no time mentioned, the system will ask the user what time and will do so twice. And if in the 2 attempts there's no positive outcome, there would be a cancellation of this recognition, and they will be again asking the user to repeat the order. And the same thing for the time and the temperature, twice. Now, the execution or the implementing of the order, there are 2 types of requests: to carry out an action, like simple actions like turning the light on, opening a window,